All right, let's get into it. We are doing a deep dive on a piece of hardware with probably the most technical name I've seen in a while. It's the Thor Broadcast H-2HDMI-QAM-IPLL 2CH HDMI to QAM encoder modulator.
Yeah, that is quite a name. But the mission behind it is actually pretty straightforward. It's really just a bridge
A bridge between what and what exactly?
between, your modern HDMI signal, that beautiful 1080p video, and the old coaxial cables that are probably already in the walls of your building.
And the really interesting thing, the hook, is that this box, and yeah, let's just call it the H2QAM modulator, it does three things at once.
Right. It's an encoder, it's a modulator, and it's also an IPTV server.
So you can take pretty much any live HDMI source and just kind of blast it out onto its own RF channel.
Exactly. And you get perfect HD quality up to 1080p 60.
Okay, so let's talk about the functionality. What kind of inputs are we looking at here?
Well, it's got the basics covered, two HDMI inputs for your local sources. But the really important one, the critical one, is the ASI input.
Okay, ASI, asynchronous serial interface. So for someone who isn't deep in professional broadcasting, why is that so much more important than just having another HDMI port?
It's because ASI is, it's the standard language for pro broadcasting.
Oh.
So it lets you bring in streams from, say, a satellite feed or another professional system and mix it right in with your HDMI stuff. It makes it a pro-grade device.
Got it. Okay, so moving on to the encoding. It does H.264, which is what you'd expect, but it also does the older MPEG-2. I mean, H.264 is so much more efficient. Why even bother with MPEG-2 anymore?
That's a great question, and it really comes down to compatibility. You might have a huge facility, a hospital, or a university with thousands of older TVs that can only decode MPEG-2. So you need both options to make sure it just works everywhere.
And this is where it gets really cool for me, the LL in the name, ultra-low latency.
Yes.
It claims to take the delay from, what, over a full second, like 1,200 to 1,600 milliseconds?
Yeah, which is pretty standard for a lot of systems.
And it just crushes it down to somewhere between 70 and 250 milliseconds. That is a huge difference.
It's massive. Think about live security feeds or, monitoring a live event. A 1-second delay is a problem. 70 milliseconds. That's almost real time.
Is there any trade-off, though? Do you lose noticeable video quality when you push the latency that low?
Surprisingly, very little. The quality stays at HD 1080p 60. The speed really comes from the dedicated hardware inside the box. It also supports high-end audio, by the way, AAC, Dolby AC3.
Okay, so we've got this super fast encoded signal ready to go. How does it actually get onto the old copper coax cable?
That's the modulation part. It uses QAM, specifically QAM64 and QAM256.
Right, quadrature amplitude modulation.
Exactly. It's just the language that lets the cable system package all that digital data onto an analog RF channel.
And that leads us to the big picture here, the head-end solution. This isn't just about one channel.
Not at all. The whole point is scalability. This is how you avoid tearing open walls to run new fiber.
Which is incredibly expensive.
Hugely expensive. Instead, you just stack a few of these boxes, you daisy chain them, and there you go. You've built your own custom headend with dozens of HD channels running on the wiring you already have.
And managing it all.
Super simple. It's all controlled through a standard web server. You just log in from a browser.
So, to sum it all up, this Thor H2QAM modulator is basically this powerful, really low latency bridge.
Yeah, it solves a very specific, very common problem.
It connects new digital HD sources to old analog coax systems, and it does it all in one box: encoder, modulator, and IPTV server.
It's the ultimate tool for infrastructural efficiency. We've talked a lot about how it creates those QAM signals for the coax.
Right. Which leaves us with a final thought for you, our listener, to sort of noodle on.
Yeah.
If this box is busy creating these special QAM signals on one end, what has to be on the other end? What piece of tech hidden inside every TV or set-top box is needed to actually catch that signal and turn it back into a movie you can watch?
Something to think about. Until next time.